Hello, in this workshop, we're going to create a new Omnichain contract and call it from Bitcoin. We're also going to look into how to create a very simple web interface using XDeFi and call that contract from a browser extension. Let's get started. First, you want to clone a template from ZetaChain's repository. So if you git clone from this URL, you will have a new directory called template. This directory is almost empty, it just contains configuration files, but it includes a lot of functionality. One of these features that the template has is you can create an Omnichain contract in just one command. If you use the Omnichain command, you can see that first you need to install dependencies with Yarn. You can also use npm. Now that dependencies are installed, you can check out the Omnichain command. It accepts the only argument that it needs is the name of the contract. It also optionally accepts arguments, but we're not going to use them today. So let's say Omnichain and the name of the contract is going to be my contract. This command created a new contract in the mycontract.sol file. It's very simple. It just implements ZContract, and it has only one function that gets called whenever tokens are transferred to a TSS address. So the way Omnichain contracts work is every connected chain has a special ZetaChain address called TSS, and when tokens are transferred to this address with data field if it's an EVM chain, or in a memo if it's Bitcoin, with data in a memo field, this data contains the address of this Omnichain contract and all arguments that get passed as the message. So whenever tokens are transferred this way to the TSS address, this function gets called. By default, it doesn't do anything. It just checks that this function is called by system contract, which is important so that nobody else but ZetaChain protocol can call this contract. And yeah, so on cross-chain call just gets called whenever tokens are transferred to a TSS address. Let's compile the contract. Okay, now we have the contract compiled and we're ready to deploy it. By default, the Omnichain command also generated two tasks. One is to deploy the contract and the other one is to interact with it. We're going to be using the deploy task, but not going to be using interact task because we'll be sending data from Bitcoin using native token transfer instead. Okay, so we can look into the deploy task, but before we can deploy, what we need to do is ensure that we have an account with tokens, both on ZetaChain as well as on Bitcoin. So if you type account, the template will create a new account for you. If you also use the save flag, it will save this private key to the .env file. I already have a private key there, so I don't need to do that. But once you save your private key, you can now go to either ZetaChain's Discord to get testnet tokens, or you can use the built-in faucet here to get Zeta tokens on ZetaChain. You also need testnet Bitcoin, and you can find testnet faucets. I've been using coinfaucet.eu, seems to be working fine, so you can use that. Okay, now that you have acquired testnet tokens, you can use the balances command to check the balances on all the chains, on all the connected chains. We can see that we have both Zeta tokens as well as testnet Bitcoin. Okay, what we can do next is use the deploy task to deploy the contract to ZetaChain. We're going to be using the network flag to specify the chain. It's important to note that Omnichain contracts are always deployed only to ZetaChain. You don't need to deploy them anywhere else. And the task will actually throw an error if you try to deploy it somewhere else. Now we have a contract deployed. We can view it in the Explorer on ZetaScan. It's very convenient. And we can also view it on another Explorer called Block Scout. If you click on the contract tab, you will see verify and publish command. I've already verified this contract before, so it automatically verified my contract. But if you publish a different contract, you will need to provide a flattened contract source, and you can get it from the build info directory. So you can see that we have on cross-chain call, so Block Scout now knows about our contract. Okay, so what we want to do next is we want to actually call this contract from Bitcoin. So we have testnet Bitcoin. All we need to do is, well, find a way to call this contract and know how to do this. So the template has a command called send BTC, which is very helpful because it's a simple TypeScript command. I'll show the source code um, for it later, but it's a command that essentially prepares the transaction and broadcasts it to the Bitcoin testnet. So it expects to receive an amount, a memo, and a recipient. So let's call this command send BTC. I'm going to provide a very small amount, doesn't really matter, just 0.001. The memo, this is where it gets interesting. So when you send tokens to a TSS address, they get deposited on ZetaChain into your account as 0C20. What you also provide a memo with a contract address that a contract on ZetaChain gets called, and these tokens are passed to this contract as 0C20. So the memo has a specific format, and you can read more about it in the docs. If you go to zetachain.com/docs, Omnichain, and Bitcoin, you will see what exactly needs to happen on Bitcoin for this transaction to be successfully interpreted by ZetaChain. But from this point of view, what you really need to know is you need to pass the contract address in the memo field and without 0x. So in our case, this is the contract address, and we can paste it here. And that's all we need to do really for this contract because it doesn't really expect to get any arguments. But let's say your contract expects to see something in the message, for example, the recipient address. And let's say your recipient address is your address in this case. So you would copy that without 0x, and your memo would look something like this. So the first part is the Omnichain contract address on ZetaChain. Everything else are arguments passed to the contract in the message. Okay, so even though our contract doesn't expect to see anything in the message, we can still pass this as the memo. And we need to specify the recipient. The recipient is the TSS address on ZetaChain. You can get TSS address from the testnet in the tools section. type BTC, you will see the testnet address. It's the same for all Omnichain contracts, so you can just copy it, paste it here. Okay, this looks good. So we're sending a small amount with a specific memo to call this contract that we've deployed, and we're specifying the recipient as the TSS address. Okay, you can check the transaction and confirm. The task returns a transaction hash. This is useful because you can now go to Bitcoin testnet explorer like Blockstream, paste the transaction hash, and you will see the status. Right now it's unconfirmed. As soon as it gets more confirmations, I believe it's 3 or 4 confirmations, it will be processed by ZetaChain. You can also use the cctx command and pass the transaction hash, and it will start looking for this transaction on ZetaChain. As soon as it finds it, it will tell you the cross-chain transaction hash, which you will be able to then use on Zetascan and see the progress of the cross-chain transaction there. You can also monitor on BlockScout. Okay, so it might take a while for this transaction to be processed. So let's look into how you can broadcast the transaction from the browser. So in the developer section in Omnichain tutorials, there is a Bitcoin front-end tutorial. And to save some time, let's just follow this tutorial and look into what the code does. So first we need to create a new project. Let's create a new directory called frontend. And let's initialize a project. Now we need to install the HTTP server. It's optional, but it's handy. So the whole application is going to be a simple HTML page and a JavaScript file. So let's copy this HTML. So what this HTML file does is basically renders a few inputs and a button. It also loads a script from script.js. Okay, now let's copy the script.js. This is a bit more complicated, but it's still pretty straightforward. So it first defines the TSS address that we already used to transfer tokens. Then it fetches the wallet from XDeFi. XDeFi is a wallet that supports ZetaChain, and it can broadcast transactions with a memo in a specific format. You can learn more about it on their website. So you need to install it and add an account to it. It's pretty straightforward. And you can also request tokens to this account as well. So you will get a wallet from XDeFi. I mean, you're not going to get the whole wallet. You're just going to get Wallet's API and access to the accounts that this wallet contains. And you need to get the account because the transaction requires the sender's address. Then you just get the values from the contract field. You ensure that it doesn't include 0x in the beginning, and you include all the params. By default, the memo is empty. You don't need to specify it, but you can. And if there is a contract value in the contract input field, it will create a memo. And the memo format is very simple. It's almost the same as we had in the terminal earlier, but XDeFi requires hex : to specify that it needs to be encoded in a specific format that we already saw in the documentation. So we then parse the amount and create a transaction. So we're using XDeFi's Bitcoin API to create a request. It accepts one object. You specify the method params, which includes the from, which is your account, recipient is the TSS address, and the amount as well as the memo. So all of this looks good. Now let's run the command to, well, start the server. npx http server. And we have a very simple UI here. So let's check that we have enough tokens. We have some test BTC. So let's specify 001. Omnichain contract address. We can copy from the text editor that we use to deploy it. So this one, we can remove 0x, but it removes it automatically. And we can also paste an argument, even though this contract doesn't expect to receive an argument. It doesn't do anything with it. So yeah, you provide an amount, contract address, and params. Pretty straightforward. You could have multiple params, and you press send transaction. So check that you supplied the correct amount and that the memo starts with hex : So this looks good. And when you broadcast, it should broadcast the transaction. It's not going to return the transaction hash, but if you go to the console, you'll see the transaction hash here. You can copy it from here. And so we've got one confirmation for the transaction that we sent earlier. We can paste the transaction that we used from XDeFi. Of course, it's not confirmed yet. You can also go into the details and see that your data has been encoded correctly. I mean, you can't read it, but you can see that it's in binary. You can see that the OP return is the second output, which is important. And yeah, if it looks something like this, then chances are you've encoded the transaction properly. So XDeFi, the latest version, make sure to install the latest version of XDeFi, which supports encoding the memo correctly. So once that's done, you will be able to see this transaction on explorers, specifically on ZetaScan. So again, if you go to your template, it's still looking for the transaction because it hasn't been confirmed on Bitcoin testnet yet, but once it does, you will see a cross-chain transaction hash here, and you will be able to see the transaction, the full life cycle of a transaction on ZetaScan. So this was a quick overview of what you need to do to get started with Bitcoin. It's pretty straightforward. With just one command, you get a contract. You can implement the functionality you need. So the tokens that you sent, you will receive as 0C20 here, and you will be able to lock them and mint NFTs or mint your C20s, or you can swap the tokens. Well, it's up to you really what you do, but you can also pass arguments. So it's not only just tokens, but you can pass value. You can pass data from Bitcoin and use it. So that could be useful for all sorts of things, including NFTs. Maybe it's a name of something, a number, rarity, and then you can handle this on cross-chain call. That's it. Thanks so much for watching and happy hacking.